Every adjacent angle is congruent. Is that 100% true all the time?
No, it's false.
It's false because?
Because they're not always the same measurement of degrees.
Yeah, they're not always the same measurement of degree. Thank you. Can someone else tell me just what the different definition of adjacent is? Or what are two adjacent angles? How do we know they're adjacent? Yeah. It has a common side and sorry, I screwed up what you said. But yeah, it has a shared side and it has a common vertex. Can someone else tell me what congruent means? What does it mean to be congruent? If I have two equal angles, or congruent angles, what does that mean? Yeah. Same shape and size. We're looking for the exact same measure. You brought up the measure, right? So this is going to be a false statement because it's not true 100% of the times. So it's false. And a counterexample, you can even either say what you said, just put, there are some adjacent angles that are different sizes, or I said we could draw a counterexample. And drawing a counterexample might be something like this. I'm going to draw two adjacent angles, so I'll put that right there, maybe like this. Obviously, they're not congruent angles. If you want to go one step further, you could say something like this is, 55 degrees, and this is 12 degrees. All right, so sometimes it's easier in words to put a counterexample. Sometimes it's easier just to draw a picture and say, hey, look, Mr. Pavian, those are two different sizes, and they're adjacent. Do we all agree now that this is a false statement? It's not true 100% of the time? We're all okay with that? All right, cool. We're going to switch things up a little bit now that we're kind of getting the flow of things. So what I like to do is I will, and remind me if I forget this, I'm going to run through the lesson, and then I'll ask for questions on the homework before, because there are some people that don't have questions, and they can continue to work then, versus having to sit through the questions and be like, I know this. All right, so we're going to push through the lesson, and then so save all your questions on the homework from last night till the end. I will get to them. All right? All right, today we are talking about if-then statements and converses. An if-then statement, so we're going to start out calling them conditional statements, but they're the exact same things. We're going to have something called a conditional statement. It is a logical statement that has two parts. It's going to have a hypothesis, and it's going to have a conclusion. So the first thing is it's going to have a hypothesis, and it's going to have a conclusion. Our hypothesis is if this happens, our conclusion is then something happens after that. So my example up here is, for my hypothesis, I said if I work hard, so this is going to be called our hypothesis, if I work hard, that says had, hard, our conclusion is then I will pass the class. So once again, our hypothesis is like our setup. It is if this, and our conclusion is, well, then this will happen. If this, then this will happen. So if we look down here, this is a conditional statement. It says, if it is sunny after school, then I will play basketball with you. So we have two parts. We have if it's sunny out, or sunny after school, that's our hypothesis. Then I will play basketball with you. That is our conclusion. Now, as the header of our title implies, we don't always just call these conditional statements. Sometimes it's a little easier to call them if-then statements. So we can call these if-then statements. In other words, conditional is the exact same thing as me saying if-then. They're interchangeable. So if I say conditional, you can think if-then. If you like the word conditional and I say if-then, you can think conditional. So that's all this bottom box is for. A conditional statement equals an if-then statement. I kind of like them called if-then because it tells you kind of how to set it up. If this, then that. Versus conditional, which is, you said, remember, it's an if-then statement. Any questions on that? If-then statements are basically the bulk of this. All right, we already went through that. Some symbology stuff. So to represent conditional statements symbolically, we use a P to represent the hypothesis. And we use a Q to represent the conclusion. Because it's not fun to write hypothesis and conclusion over and over and over. So in your homework, you'll have a part where you have to say, is this a hypothesis or conclusion? You can use P and Q. So how this to be written is if P, if our hypothesis, then our conclusion. If P, then Q. So once again, that P stands for a hypothesis. That Q stands for our conclusion. So if it is sunny out after school, that's our hypothesis, which you can either write as P or as hypothesis. Either way, correct. And then our conclusion is, I will play basketball with you. That is our conclusion, or Q. So P equals hypothesis, Q equals conclusion. It can save you a whole bunch of time, especially if you have to write hypothesis and conclusion over and over and over on a homework. P is hypothesis, Q is conclusion. Now you don't have to use those. If you're in the homework and you want to write a hypothesis every single time, good on you. Have a good time with it. This is just a slight shortcut. All right, converses. The converse of a conditional is formed by interchanging the hypothesis and the conclusion. So you just take your conclusion and your hypothesis and you switch them. So once again, you're interchanging your hypothesis and your conclusion. The hypothesis and conclusion. So on the other side, we said if P, then Q, right? So a normal statement would go something like if P, then Q. If our hypothesis is true, then something comes out of it. If I ask for the converse of that, you're going to switch your P's and Q's. All right? Your converse is going to be if my conclusion happens. So if Q, then P. So if I ask for the converse, you just have to know what your hypothesis and your conclusion is and flip their two spots. Does that kind of make sense? Yeah. I'm just pointing out if P, these are our two interchangeable things. If and then pretty much stay put. These are two things that we flip for converse. If you don't want to underline them, you don't have to. All right, so in our next one, we have a statement. It says, if I win the lottery, then I will buy a boat. If I win the lottery, then I'll buy my boat. Now our hypothesis is right here. That's our P. Our Q is, I will buy a boat. To write the converse, you just have to flip those two things. You just need to flip those two statements. So rather than it being, if I win the lottery, we're going to take this Q and put it in its place. So the converse of the statement is going to be if, and sometimes you have to change the wording a little bit. Like, if I will buy a boat, kind of doesn't make sense. So you're going to put, if I buy a boat. Then I win the lottery. I shouldn't underline and then. Just then I win the lottery. Yeah.
Can you put will win the lottery?
Yes. Yeah, you could put I will win the lottery. Either way is fine. I'll put the will in there. Does this statement necessarily make sense? If I buy a boat, then I will win the lottery. Do you typically buy a whole bunch of stuff and then say, I'm going to win the lottery, don't worry about it? No, the converse doesn't always make sense. All right, in fact, sometimes the converse is 100% false. In fact, sometimes your statements are false. So just because I'm asking for the converse doesn't mean it has to be a rational idea. I'm just asking you to flip those two things. Because when you get to higher up math, there are going to be times where you need to flip stuff and check stuff. All right, we're just kind of building up to all that stuff. All we need to know right now is we have a hypothesis, a conclusion. If I ask for the inverse or converse, you flip the two. All right, that's all I'm asking. In fact, I said right here, a statement and its converse may say different things. In fact, some true statements have false converses. So we have a statement. If Brian lives in Wisconsin, then he lives north of Mexico. Is this statement 100% true? Is it always true that if Brian lives in Wisconsin, he must be north of Mexico? Is that true? Is there anywhere he can live in Wisconsin that's south of Mexico? You gonna get what I'm asking? So is this statement always true? Yeah, it's always true. No matter where he lives in Mexico, he's always going to be north of Mexico. Let's go ahead and write the converse. The converse of the statement would be, if Brian lives north of Mexico, then he lives in Wisconsin. So we said the statement above it was true, right? We said that's true, 100% true. That is true. No matter where he lives in Wisconsin, he's going to be north of Mexico. Is the second statement always true? Is the second statement true? I see a lot of people shaking their heads. Yes or no? Someone said no. Why isn't it true? Remember, it has to be true 100% of the time. What's a situation that would make that false? It would follow that along, but it'd be false. Yeah. If you lived in California. Yep. Is California north of Mexico? Yeah, it is. Maybe we should pick something like North Dakota. Yeah. Hawaii. Is that north of Mexico?
No. You said something not, right?
What was that? No, I'm trying to say something that would make this false. So this statement's saying, if Brian lives in Mexico, then he has to live in Wisconsin. Minnesota. Does that fit the first start? If he lives in Minnesota, is he north of Mexico? Is he living in Wisconsin? No. So is this a true statement? No. Remember, to be a true statement, it has to be right 100% of the time. There's no exceptions. So this is false. He could live in pretty much any state. He could live in Canada. He could live in the North Pole. All these places are north of Mexico, but they're not Wisconsin. So for a statement to be true, it has to be 100% true no matter what. There can't be any exceptions. All right, that leads us to a counterexample. A counterexample. So a conditional statement can only be true or false. It cannot be, it's kind of true as long as I put in this little box and I make everything perfect. It is either 100% true or 100% false. An if-then statement is false if even one example exists. That makes it false. So even if there's one example, it needs to be a false statement, even if it's just one. So that example that you find is going to be known as a counterexample. Remember, it takes only one counterexample to disprove a statement. So we already disproved this one. We said find a counterexample of the converse. If he lives in Mexico, then Brian lives in Wisconsin. So we said California. We said Minnesota. I said Canada. I said the North Pole. All of these are counterexamples. So put whatever you want in here as an example of something where he lives north of Mexico, but he's not in Wisconsin. So this is your box. You can put as many counterexamples as you want in there. Make sure you at least have one counterexample. Not to beat a dead horse, but once again, a counterexample makes the first part true, but the second part false. So Minnesota is north of Mexico, but it's not Wisconsin. So counterexample, the hypothesis is true, but the conclusion is false. Does that make sense? So the first part you're proving true, but the second part is false. I want to pick something that's north of Mexico, but is not in Wisconsin. All right, a biconditional statement. A statement is biconditional. It's biconditional if the conditional and its converse are both true. So if you say it's true, and if you flip your hypothesis and conclusion, it's also true. So it's if the conditional, or if then, if the conditional, the original statement is true, and the converse is also true. So the one above is not biconditional. So let's go back up to it real quick. This was true, but the converse was false. So it's not biconditional. You need to put true by both of these in order for it to be biconditional. So let's look at this example. So the conditional is if 4x equals 20, then x equals 5. Is that true? Yeah, it basically says, x has to equal 5. Plug that in, it's 20. The converse would be if x equals 5, then 4x equals 20. Well, the only way for this first part to be true is if x equals 5. And if I plug 5 in here, 4 times 5 equals 20. Both directions are true, right? That's what makes it a biconditional statement. When we're using biconditional statements, we're going to use a phrase called if and only if. Do you see we have two statements? I'm going to rewrite this as one statement. Pay attention to this. This is important. This is something that a lot of people miss on the test. How to rewrite two statements as a biconditional statement. So my advice to you is maybe put a star by this section, since a lot of people miss this. We are going to take these two statements and we're going to put them into one statement. When we do this, it doesn't matter which one we pick for which direction. I'm just going to take this top one. This is how we're going to rewrite this as a biconditional statement. We're going to write 4x equals 20, and then we're going to write if and only if, and then we're going to put the second statement, x equals 5. This is saying both these statements all at once. This statement is saying 4x equals 20, or if 4x equals 20, then x equals 5. And it's also saying if x equals 5, then 4x equals 20. That is putting two statements as one biconditional statement, but both directions need to be true. Are you okay, Will?
Okay.
Oh, okay. You just looked angry at that. So when you're asked to put something as one biconditional statement, you need to just write one statement with if and only if. There are other ways to write conditional statements. The one you're going to see most of the time is this if-then statement. If your hypothesis, then your conclusion. We can also use the word implies. Check out the order of this. It's still hypothesis and conclusion if you put implies between. This is still saying if this, then that. If I use only if, it is once again our hypothesis, only if, conclusion. Check out the last one. Check out the last one. This is the one you have to really pay attention to. So this is the one you probably want to put a star by, that if you see this, this is what happens. If you just use the word if, then our statements are actually out of order. It is our conclusion first and our hypothesis first. So this is kind of that weird one where you flip your hypothesis and conclusion. So my advice to you, especially in the homework and on the test, is if there's just one if in between it, you need to recognize that your hypothesis and conclusion are changing place. Because in your homework, I'm going to ask you what is your hypothesis and what is your conclusion. You need to know which is which if I put in just the word if in between it. Only if still works the normal direction. It's just if there's one if. There's too many ifs. If. Questions? Comments? Concerns? All right, let's run through a couple problems, and then I'll go through our homework questions. All right, we're supposed to state the hypothesis and the conclusion of each conditional. Can someone name the hypothesis of number 1? What is the hypothesis of number 1? Yeah.
2x minus 1 is 5.
Yeah. Remember, we can put P for our hypothesis. Just put P is 2x minus 1 equals 5. So that must mean my conclusion is x equals 3. Or apparently we have two number 3s. Let's do this number 3 first. What is our hypothesis in our first number 3? What is our hypothesis of our first number 3? Think about it, write it down, and then I'm going to call on you, okay? Think about it, write it down, write down your hypothesis, write down your conclusion. All right, what is our hypothesis?
Y equals 5.
Y equals 5 is our hypothesis. I'm going to tell you right now, that is our conclusion. Yep. Our hypothesis is going to be 8y equals 40. And y equals 5 is going to be our conclusion. Let's check y. Let's go back to this thing. If there's implies in between, here's implies, it means that our hypothesis is first and our conclusion is second. Does that make sense? Are you okay with that?
Sure.
You sure?
Sure.
Okay. So even though it says implies in it, it still works as the if 8y equals 40, then y equals 5. The only time you have to worry about your hypothesis coming second is if there's just the word if in between. All right, so let's combine the following conditionals into a single biconditional. I'm going to go ahead and do this one. Well, first of all, I'm going to look at this. Angle 1 is congruent to angle 2 if measure of angle 1 equals measure of angle 2. I do want to point out that this is the one that has the if statement in between. So this would actually be our hypothesis would be our measure angle 1 equals measure of angle 2, and this would actually be our conclusion. That's the only time it flips. But if I'm writing just a biconditional, it doesn't matter which order you write it in, so I'm just going to go angle 1 is congruent to angle 2 if and only if, and then I'll do my second statement, measure of angle, well, I should probably put it in the right order. Measure of angle 1 is equal to measure of angle 2. Make sure you know how to do those. All right, number 4 says provide a counterexample to show that each statement is false. You may use words or diagram or draw a diagram. So it says if AB equals BC, or in other words, if AB is congruent to BC, then B is the midpoint of AC. I want you right now, that's a false statement. Come up with a drawing that makes it false. And my hint is we did this in a bell work. We did this exact problem in a bell work. It was that one that I said was a trick question. You can always look back at your bell works. There's no shame in reviewing work we've done. That's why we write it down. So it's saying AB is congruent to BC, then B is a midpoint of AC. Now in that bell work, most of you said that was a true statement, that it had to be true. But if you remember, I did a drawing that looked like this, where I made this A, B, I made this C, and I made AB congruent to BC. This is a false statement, and this is our counterexample. AB equals BC, but B is not the midpoint of AC. All right, number 5 says to write the converse of the conditional and state whether it's true or false. Can someone come up with the converse for me of this one? I'm looking for the converse of this statement. Yeah, thank you.
If tomorrow is Saturday, then today is Friday.
Perfect. You just take your hypothesis, right, and your conclusion, and you flip them. So if tomorrow is Saturday, then today is Friday. True or false? Is there ever a time where tomorrow is Saturday, but that day is not Friday? Yeah. This is true. If tomorrow is Saturday, it must be Friday. I can't on Wednesday go, oh, tomorrow's Saturday. I can't on Monday go, oh, tomorrow's Saturday. The only time that works is if it's Friday. So this is a true statement. Remember, we're looking for something that makes this first part true and the second part false. I can't think of any days where tomorrow's Saturday, but it's not Friday. Unless you come up with a whole brand new calendar, which isn't fair. That's cheating. All right, questions on anything we covered so far today? We're okay? Make mostly sense? Gets a little more shored up when you're actually doing the problems over and over and over. My big advice to you is know how to write two statements as biconditional. Go back to this chart when you're going through those problems that have it in different ways other than if-then, so you know where your hypothesis and where your conclusion is. Because if there's just an if between it, those two things have actually flipped places. All right, then that being said, let's go back to homework questions from 1.4. So that'd be the homework that was due today. What questions do we have? Yeah.
How do you do 17?
Sure. 17. Let's go ahead and take a picture of those. So we're supposed to complete the statement based upon that picture, right? So let's just take a picture of all of it. I'll erase the answer, and we'll do that. All right, number 7 says, if measure of angle 1 equals measure of angle 2. So let's go back up to this drawing and highlight what we're talking about. We are looking at angle 2 and angle 1. And we are saying those two things are congruent to each other. So then I'm going to look back at my notes and I'm going to say, well, if two angles are congruent and they have a shared side, they're adjacent. They're adjacent angles, but that doesn't really help me because it says then something bisects something. So I'm going to look back at what it means to be a bisector. A bisector is a ray that cuts an angle smack dab in the middle. So it's just saying this ray right here cuts this big angle right down the middle. So that's why I put LE bisects that big angle ALS. Good. Other questions? Questions? Let's ask them. Going once. Twice. All right, let's go ahead and just start the homework if you haven't already.